A very good evening. Myself Bhavesh Parmar and currently I am pursuing my masters from IIT Delhi. So our today's topic is quadratic equation. First of all, an equation consists of two major components. First one is constant, which is nothing but the real numbers, and second one is variables, which are any alphabet or symbols, anything else like x, y, alpha, beta, etc. And one more thing is the quadratic refers that the maximum degree of this equation is 2. So from here we can see that the general form of quadratic equation can be written as ax square plus bx plus c equals to 0. And if somehow we get any x which satisfy this equation, which is by putting the value of x in this equation, we will get the value of LHS to be 0. Then that x can be said as root of the equation. And we have a very famous formula to get the root of a quadratic equation, which is given by x equals to minus b plus minus root over of b square minus 4ac upon 2a. Now, the term which is inside this square root is denoted as discriminant, which is denoted by capital D. And majorly, the value of this discriminant decide that what is with the nature of the roots. And for this, we have three cases. One, three. First one is D strictly greater than 0, D equals to 0, and third one is D less than 0, strictly less than 0. In the first case, suppose that the value of discriminant is strictly greater than 0. Then the square root of a strictly positive number is again a real number, and by adding a positive real number or subtracting a positive real number, we will get two real and distinct root. But if somehow this d becomes 0, then square root of 0 is again 0, and by adding and subtracting 0, we will not get any different numbers. So here we will get the root as real but equal. And in the third case, the square root of a negative number, it never goes in the range of real number. For this, we will have another system of number which is complex number. So here we will get imaginary roots. So by this, we can let's have an example to see that how this works. So let's have an example like that x square plus px plus 5 equals to 0 is some given equation, and we have to find the values of p for three different types of roots. So in the last slide, we have just seen that the nature of the roots depend on the discriminant of the equation. So the formula of discriminant was b square minus 4ac. And from the general form of quadratic equation, we can see that here a equals to 1, b equals to p, and c equals to 5. Now, the value of discriminant become b square means p square minus 4ac means 4 into 1 into 5, which is equals to p square minus 20. So the three cases for the nature of the roots are d should be greater than 0, d equals to 0, and d less than 0. Here p square minus 20 is greater than 0. Here p square minus 20 is equals to 0, and here p square minus 20 is strictly less than 0. This implies that p square is greater than 20, which implies p square p greater than root 20 or p less than minus root 20. From here we get that p square equals to 20, which implies that p equals to plus minus root 20. And here we get that p square is less than 20 implies p less than root 20 or p greater than minus root 20. So these are the three ranges for the different nature of the roots. If we will visualize this with a real number line, then we have to divide it into three different parts: minus infinity to minus root 20, root 20 to minus root 20, and root 20 to plus infinity. So the first case is p is greater than root 20 and p is less than minus root 20. So this outer region represent that if p belongs to this part, then we will have the real and distinct root. The second one is p is equals to plus minus root 20. Means at this 2 point exactly, we will get real and equal roots. And in between these 2 points, here, we will get that discriminant should be less than 0 and the roots are imaginary. So again, suppose that the roots of quadratic equation are represented as alpha and beta. So from the formula we can see that alpha can be written as minus b plus root over of b square minus 4ac and upon 2a, and beta equals to minus b minus root over of b square minus 4ac upon 2. By using this part, we can have the relation between the alpha and beta and a, b and c. So how can we say that? Here in alpha and beta, we only get the change in the sign of this plus and minus before the square root of discriminant part. So by adding alpha and beta, this opposite sign term will cancel and we will get minus b upon 2a, which will be equals to minus b upon a. And we will get by multiplying alpha and beta minus b square minus root over of b square minus 4ac square upon 2a into 2a, which will be equals b square minus b square plus 4ac upon 4a into a into c. So this b square minus b square will cancel, 4a will cancel, and c will cancel. No, sorry. This we will get here c will, and this result as the product of root will be equals to c upon a, and sum of root will be equals to minus b upon a. So this is the relation between the roots of the equation and the coefficient of quadratic equation. Now suppose that we have a system of quadratic equation. Suppose we are given with two quadratic equations, which is represented as a1x square plus b1x plus c1 equals to 0, and a2x square plus b2x plus c2 equals to 0. Then about the, if we will say that this system has a solution, which implies that we will get a x dash which satisfy both the quadratic equation. Now we have two conditions on this. If a1 upon a2 equals to b1 upon b2 equals to c1 upon c2. If this condition holds, then we can say that they have same roots. And here we can see that we are basically having one quadratic equation as the scalar multiple of the second one. And in the second condition is, if a1 c2 minus a2 c1 square equals to a1 b2 minus a2 b1 into b1 c2 minus b2 c1. For memorizing this, we can simply write this as ac square equals to ab into bc. Here AC means A1 C2, A2 C1, AB means A1 B2, A2 B1, and BC means A B1 C2, B2 C1. So if this condition hold, then we can say that they have one common root. So this much for today. Thank you very much.